In this video, we will build ALU for our 8-bit CPU. Welcome back to the channel, guys. So in the last video we built general purpose register for our CPU. In this video we will build ALU. If you are new to this channel, please go back and watch all 4 previous videos and then continue watching this video. If you haven't subscribed to the channel yet, please subscribe and let me know your feedback in the comments below. So without wasting any time, let's get started. As suggested by one of our viewers, I have prepared a little block diagram for you guys. So this is our entity, block diagram for our entity. So it has 4 inputs and 2 outputs. So first one is enable. We will set this pin to high if we want to see the result of our ALU on our data bus. Second one is OP. So as I told in first video, the design video, our ALU is capable of 2 operations, only addition and subtraction. So OP is 1-bit line which decides which operation we will perform. Third and fourth are registers. In last video we saw how we have made a direct port from register to ALU. So these connect to those ports. So both of these registers are both of these input lines are 8-bit wide. Coming to the output, we have carry out, it is 1 bit, and result, that is again 8-bit output. So let's start to write our Vhdl file. I have already written the libraries. So let's make our entity. As always, we will save this file into our HDL folder. So first is enable pin. This will be standard logic. Second is our OP. Again standard logic. Third and fourth are register A in and register B in. Those will be standard logic vector of 8-bit, so 7 down to 0. I will just copy this. Oh, sorry, these will be input, not output. Then we will have carry out. This will be output. Not vector, this will be only standard logic. And we will have result output. this will be standard logic vector of 8-bit. So again 7 down to 0. If you notice, in all our other modules we have clock input. In this ALU we don't need clock because this is a purely combinational circuit, so we don't need to use a clock. Let's write its architecture. So architecture behave is we will write a process which will be triggered on changes in A register, B register and OP. So if OP is equal to 1, then addition, else subtraction. So here we will make a signal to store the result of our addition or subtraction. So this signal should be 9 bits wide because we have to add two 8-bit numbers, and so the result can generate a carry, so we need 1 bit extra to store that information. So this will be standard logic vector 8 down to 0. So result will be, now we have to add register A and register B, but a result and register size need to be same, so we need to extend that input to 9 bits. So we will enclose it in extend function. This is an inbuilt function, register A in comma 9, because we need 9 bits. Plus register B in comma 9. So this should give us the addition. Let's write else if OP is equal to 0, then we'll just copy this and change the sign to subtraction. So A minus B. This is, the process is complete. Now just we will assign the most significant bit to carry out. So that this will be result of like 8th bit of result. So and to result out we will assign least significant 8 bits. So this will be result 7 down to 0. So let's add this into ModelSim and check whether we have any errors. So right click, add existing file. and let's compile. Oh sorry, I did not realize I was on different screen. So I already added it. Just compile. Okay, we have one error. Okay, architecture behave of ALU is line number 33. We have some error. Okay. Okay, our ALU file is compiled successfully. So let's proceed to test bench. I'm going to copy the program counter test bench. So let's just paste it here. I'll change the name. We will change our make the changes to the component. We will save this file into our test bench directory. So let's change these signals. We don't need reset. We also don't need clock, but I'm going to keep the clocks because it simplifies keeping track of when the our waveforms change. So I'm going to keep the clock signal as is. Let's change load to OP because we don't have load here. We have OP signal. Then we need signal for register A as well as register B. I'm just changing these existing signals. Both of these are 8-bit wide, so 7 down to 0. We need signal for carry and our result. So first I will make result signal. Result out signal and carry. Carry will be standard logic. So let's change the instance or object. I'm not sure what to call this. If anyone with experience is watching this and know what can we call this instance, please let me know in the comments below. Because I come from a programming background, so I just call it an object, like in any object oriented language. So enable will be same. Just I will add OP signal here. And we will remove this. We need to connect register A in to our register A signal, register B into register B signal, and then carry out to carry signal and result out to result signal. So this is our mapping. I will leave the clock process because, as I said, it will help us to keep track when the signal changes. We don't need reset, so let's remove this. Enable. Okay. We will load a register with values. So register A signal, we will assign some value. I'm assigning 1111, like all ones, that is FF. And for register B, let's assign value 1, that is all 0 and last bit 1. So the addition should come to be carry will be 1 and the result will be 0, and subtraction should be F and E, so it will be easier for us to verify. So enable 0, first we need OP is equal to 1, then we will enable the output. So then our output should come on our output bus. Then we will make OP signal 0. And leave enable as is, and then wait forever. So this should give us a fairly good idea. So let's add this to ModelSim and compile. We have 2 errors. Near wait, expecting semicolon. Okay, I forgot to semicolon here. And our test bench is compiled successfully. So let's make one simulation configuration. We'll select our test bench. I will name it ALU sim. So let's add these signals to a new waveform. And run this. So if we zoom in here, you can see that initially our A and B are FF and 0 1, and our OP signal is enable signal is high and OP is 0. Okay. Oh, it's yeah, sorry, my bad. So initially enable is 0 and OP is 1. So Okay, I have forgot to use our enable pin in our ALU, so we need to make some changes here. So we will assign the result only when our enable is high. So else we should keep that output to high impedance value. So this will be Z. I forgot this, sorry. Same with carry. So let's compile our ALU again and test bench as well. Okay, we have two errors. Okay, apparently we cannot use this here. Okay, our ALU is successful. Let's recompile our test bench and we will restart our simulation. So let's rerun the simulation. Yes, now you can see that. So if you see here, our enable line is low, so our output and carry will be set to high impedance state. So as soon as enable becomes 1, we output the value. So our A register value is FF and B register is 1. So the addition will be 0 and carry will be set to 1. Similarly, when we change the operation to from 1 to 0, the subtraction will be carried out, and as you can see here, the result changes from 0 0 to FE and carry is set to low. So our ALU works as expected. As I said, our ALU does only add and subtract. I have not implemented add with carry, but we can do it in future. So I have not yet made a video about our instruction set. So in that video you will see that we have a very simple instruction set without any complicated instruction, and we don't use carry anywhere in our instruction set. So I have just kept the carry output so that we can extend this CPU in the future. So maybe you can comment down your thoughts. What can we do? So this was our ALU. If you like the video, please let me know your feedback. Give it a thumbs up. If you think we can improve some things, please comment down as well. A lot of our viewers are from Reddit. They give me some wonderful feedbacks on Reddit. But I request you guys to comment down your thoughts on this YouTube video as well, because it helps the video to reach a more wider audience if you comment down. If you haven't subscribed to the channel yet, please do subscribe. My goal with this channel is to reach 1,000 subscribers by the end of this year. So help me achieve that goal by subscribing if you haven't already. Share this video with your friends if they enjoy this kind of content. Thank you for watching this video and see you in the next video.